Well, hello, everybody. Welcome back to the Verizon Managed Services Podcast. This is episode 7. I'm here with Arian Osman. He is the VP of Data Science for Evolve 24. Thank you so much, Arian, for joining us today on this podcast. So we'll jump right into it. Arian, can you tell me just a little bit, about your background, how you got into technology, but specifically data science in general? What kind of brought you to that career path? Could you walk me through that?
Sure. My background, my educational background, I got my bachelor's in mathematics, got my master's in computational sciences with a focus in computational mathematics. I'm finishing up my PhD in computational mathematics. All throughout my educational career, I went to George Mason, local to the area in Northern Virginia. So I've been working full time while going to school part time. Throughout my professional career, I've held a whole bunch of roles, including software development and engineering, database administration, business intelligence architecture and implementation, and development, as well as a data scientist, an individual contributor as a data scientist. And more recently, within the last year and a half or so, I've taken up management roles, but management roles where I could still be an individual contributor. The one commonality between all of my professional experience has been data. All projects that I've worked on previously were data centric. Therefore, it only made sense for me to become a data scientist because I also had that mathematical background that's associated with it. And my PhD research is actually in the mathematics behind computer vision. So dealing with images and videos, and my PhD research is on fingerprints. So I've been able to apply my expertise in mathematics to the computer vision space and kind of expand upon that in my professional career.
That's awesome. Sounds like you've kind of, so essentially you started from the bottom and then you got more and more complex as you gain more experience. So that's really cool on the visual side of things too, with math and fingerprints and things like that. Me personally, I don't know a whole lot about, data science, but could you walk me through a few examples of, what use or what value does having data science bring to an individual business? I mean, I'm sure there's so many different ways that you can apply, data science, but could you name a few examples of how it would benefit a company, for example, like making them more profitable or, improving, internal processes? What are some examples that, either you've worked on for companies or things that you've done for clients?
Sure. So, excuse me. Let me back up a bit and explain what data science is, in a nutshell. So, data science is the combination of mathematics and statistics, software engineering and development, so computer science, but also relating to subject matter experts pertaining to a particular business. And data science is the encompasses all three of those particular facets. Now, when I break down data science, I break it down into branches. So you have the basic mathematical and statistics stuff that you would usually see in a sales and marketing team, dealing with campaigns and advertisements, so on and so forth. But then you also have, more sophisticated approaches like machine learning and deep learning. I'm sure you've heard those key terms as well. And that deals with natural language processing, which is another branch, and computer vision, which is another branch. And you can also have numerical data, which is another branch in its own. And that could be in the financial domain or whatever you want to look at to identify patterns and so on and so forth. But then there is one or two other branches, and you can break it up how that branch in however you want to, but it deals with simulation, modeling and simulation. So think of like if you wanted to, if you were working in a factory and you were producing like violins or guitars or some sort of instrument or product, you want to be able to simulate, how many workers it would take to develop a full product, right? Being able to time that out, the number of employees, how much you pay those employees. So you kind of simulate that aspect. So it's depending on the business problem that you're trying to solve. So, for a sales organization, a marketing organization, you may want to utilize data science to increase your profit margins. But also, if you deal with clients, you want to be able to increase their profit margins as well. So you can kind of extend upon that. And in the software company, such as maybe like Tinder, for example, I'm thinking that they have their own sort of AI implementation when it comes to matching and having the right partner being matched to, whoever is the Tinder profile holder. Also, Tesla, for example, utilizes computer vision with respect to, how close they are to the car, the traffic features. So utilizing that sort of aspect, being able to identify if the object that's approaching is a car. You guys see natural language processing all the time in Google, that autofill feature when you're doing a Google search. So that deals with natural language processing. And simulation, you don't see too much of that, but I think the most perfect example was the recent pandemic, the COVID pandemic, being able to kind of simulate the spread of COVID in a particular region. So that's in itself its own sort of branch in data science as well.
Sure. I mean, it's a lot of facets. I think the biggest thing that, I think about just from a business standpoint is, a business owner trying to calculate, okay, here's going to be, my productivity and accurately, guesstimating, how many products and units that I can make, how much is it going to cost, how many employees do I need? I think that's something that, is really valuable. And I think, the Tinder thing that you mentioned too, of how they, rank people. I think what I read or something is that if you make a profile, you actually get ranked like on a scale. And,
Right.
Based on that, they try to pair you up with other people that are similar to that rank.
Right.
And the higher you are, the better you do. And the lower you are, basically nobody sees you. Some of the things that I've heard from just a Tinder standpoint when you look at some of the data. But it's really cool to think about it from that standpoint. Now, I know you mentioned a few, bigger companies, like for example, Tesla, obviously Tinder's a massive organization, but have you seen, smaller companies, for example, like SMBs using these type of tools? Is it even available to SMBs?
Yeah, well, first of all, data science has grown substantially in the last 10 years. So let me start with that. It's been becoming more popular and popular. And as its popularity has grown, there are a lot of third-party tools that are available. Amazon Web Services, Google Cloud Platforms, they provide their own tooling and their own algorithmic creations. And I'm sure you've heard of the Chat GPT. There are all these tools that are available, of course, at a cost. So it depends on the organization's budget, what they can afford. And even if you're not well versed in the mathematics behind data science, there are these third-party tools that are available, and I think that's a direction that we are heading. That each organization that provides sort of data science as a service, if you will enhance their capabilities, being able to increase and handle all sorts of manipulations that data scientists do when it comes to pre-processing data and so on and so forth, and enhance and being able to analyze particular data sets as needed. And I kind of see that as a direction where data science or data analysis as a service is going to be provided more and more as time goes on. So even a small company, even if it's an individual user, I work on side projects, outside of Evolve 24, and I utilize AWS to at least develop a proof of concept. The people who don't have a massive budget can utilize, say, for example, AWS recognition for computer vision projects to develop a proof of concept. And depending on the results of that proof of concept, you may be able to promote to various angel investors or something like that about the prospects of a particular product, whether or not it's a good idea, and how well does it perform. So being able to utilize these third-party resources is kind of key, and it's quite available. It just depends on the problems that you're trying to solve.
Sure. No, that's a good thing to hear from that perspective. It's a little bit similar in the managed IT space too. A long time ago, back when I was really, really young, it was something that, included, massive amounts of budgets, huge implementations. It was something that, typically enterprise companies can only afford, that type of infrastructure. But now as time goes on and technology is more and more, commoditized for lack of a better term, that's something that, really small businesses can have those resources. And it seems like everything is moving towards, software as a service, this as a service where you pay, just a small, subscription fee, and you're able to access these enterprise level tools. I mean, even Salesforce, for example, CRM platform, 15,000. I mean, the last company I was with, we had over 15,000 employees who utilized Salesforce. Another company I was with had 50, and we utilized Salesforce. So that's really interesting to hear. I mean, from your perspective, because there's always companies out there that, are resistant to change and resistant to technology. I mean, what do you think is in store for those companies that maybe are resistant to change and adapt to, these new technologies that are coming out? Say, for example, like a data science standpoint of being able to predict output. What do you think the future holds in store for those type of companies that do not adapt to technology?
Well, this is kind of where I see it. Of course, it depends on the top of a particular organization and their vision for the organization. You'll come across some people who are stubborn in that respect. But me as a data science leader, I kind of am tasked with promoting prospects as to how data science can be utilized. And you have to understand that in data science world, a model can never be 100% accurate. It can never perform 100% correctly, and because there are all these sort of variations when it comes to dealing with predictions and so on. But what I can see, and me personally, and now I'll give you an example. A simple example. When I pay bills, I don't use automatic payments. I like being able to press the button. I like having that human aspect involved in how I'm spending and what I'm paying for and so on and so forth. And I think some organizations, if they don't want to go fully data science, I kind of see that they will at least want to include the human aspect into their processes and probably utilize data science as an additional resource in order for them to make the right decision. Of course, in data science, you have how confident is this particular prediction? How confident is this image a cat? How confident is this image a dog? So you have a probability of saying, 70%. Well, there may be some outlying factors that are outside of that data science prediction that you do have to take into account, whether that's incorporated in a model or whether you have that additional human element. So if you introduce it in that respect, because in business, some people go with their gut, right? So, and I deal with that myself, even when I develop data science models. I go with my gut in making a decision as to which way I should approach a particular problem. So you can kind of relate to people, to organizations that are more stubborn when it comes to change, but at least being able to clearly articulate the pros and cons as to what and how data science can be utilized by an organization, and what the prospects are, because I think that if you rely on data science fully, it's a big mistake. I'll always say that. It's a big mistake. I think of the Terminator movies when this comes into mind. But when it comes to having that sort of human element involved, and going with your gut and your experience, I mean, nobody can really overcome that and overpower that, and you just have to ensure that you utilize it as a resource, rather than it being a full replacement of a particular task.
Sure, and that makes sense from a lot from that standpoint too, especially with ChatGPT. I mean, it's really, really good. I've used it, but at the same time, for example, if it says like, hey, write me a fitness workout program, or write me, I mean, article on, the ketogenic diet for weight loss. It's really, really confident in terms of how it writes it, but it's not always accurate. Sometimes there's things that are just completely off from that standpoint where you need somebody and you need that human aspect looking at it. I mean, yeah, it can probably do a lot of the legwork and essentially automate a lot of the human element in terms of the time required to go out and do these things. But at the end of the day, right now there needs to be somebody, reviewing it and making that ultimate decision, kind of like you said before,
And,
from
and
that
it's like,
standpoint.
and it's like, if I relate it to the fitness industry, and I just thought of this problem today, because I work with personal trainers, and I have a personal trainer, I have two of them, in fact, and been trying to get in shape, and I thought of this idea where I'm measuring my lean body mass and my body fat percentage, and being able to kind of relate that to my eating habits and so on and so forth, and then based on that, being able to predict the trend and forecast my trend of the increase in my lean body mass and the decrease in my body fat percentage. But of course, there's that added variable because you cannot predict how much am I going to eat. If somebody goes off their diet, I mean, there is that sort of twist and turn right there. And that's that one variable and a perfect example as to where that human element comes into play. Unless you're following the strict sort of diet plan or what have you, and you can ensure that it's being fully monitored, your predictions may become invalid, which is why there's that sort of additional twist and turn that may be evident in a data science implementation.
Sure. No, that makes a lot of sense too. From that standpoint, I guess kind of the next segue would be, what does the future look like for artificial intelligence and AI, and what you see going on, and the trends that you see going on right now? Because obviously we've talked a little bit about that human aspect, but do you think it'll get to a point, maybe in the next, couple years, or maybe even 10, 20 years down the road, where it'll be so good where you don't need that human element? I mean, what are your thoughts on what the future looks like from an artificial intelligence standpoint?
From an artificial intelligence standpoint, and from a data science development standpoint, let me back up a bit. So when I define a data scientist, and some people may agree with me, some people may disagree with me, but there's a difference when you hear the term data scientist and machine learning engineer. There's an actual difference, and the main difference is a machine learning engineer may not necessarily care about the mathematics or statistics behind implementing a data science model, but are more concerned with the flow and the development and putting it in a production environment, meaning that it's live for a data science model to consume. And I see, as we go into the future, there will be a reduction in the number of data scientists, if you will, and an increase in machine learning engineers being able to implement data science tools for consumption by various organizations. So an increase in the utilizations of services that are provided, for example, by AWS or Google Cloud platforms. Databricks is a good example. So I see that direction being more clear when it comes to the future of AI and the development of AI. So there are data scientists that are more well versed in the theory and the aspects of data science as it comes to algorithmic development. But then there's going to be that increase in machine learning engineers from developing and deploying models for consumption, but also machine learning engineers to be able to consume and implement models from their end, having these models talk to each other, platforms talk to each other. I think that's going to be the future within the next 4 or 5 years or so. I don't anticipate that the human element will go away in the near future, but I don't have a crystal ball and I am not a mind reader. But at least in the short term, I can see more tools being developed with respect to how data is consumed, processed, and implemented from a machine learning and artificial intelligence standpoint, but also being able to be consumed by various organizations in different ways, and the combinations of different data types. I think that's an added dimension as to where it would go.
Sure. No, that makes a lot of sense. From that standpoint, just having things talk to each other, but that human aspect is not going away anytime soon. And then one example I think about, is just in terms of Tesla's self-driving car. I know they were saying, back in 2016 they want to have it fully automated, but even now still it's not, it's partially automated, but there's
Yeah.
still you still need somebody driving it.
Yeah,
At the end of the
there's
day,
always going to
controlling it.
be some sort of bug or something, and you know, when it comes to detecting objects, I mean, think about this. Think about it in this way. The first automobile wasn't, created until like the early 20th century or something along those lines, and we are creating new things every day. So new things may pop up on the road. Maybe we've seen those weird three-wheeled vehicles. I mean, there may be another form of vehicle that comes into play. We see I think the Segway was what it was called. And there are new objects that are appearing on the street. So we have no idea what new objects are going to appear on the street, but what we know at least what I know from a data science standpoint, that the existing models that they're using will have to be retrained to account for those new objects that we see. So it's going to be an iterative process, and it always will be an iterative process as new things are being developed. So I can't really see unless a model can predict what type of technologies will be built in the future to address that particular example when it comes to Tesla, because you don't know how. I mean, a plane. I mean, for example, could fall from the sky. I don't know if that scenario was covered. I mean, there are all sorts of things that you can't really account for, but at least you're able to determine from an AI standpoint whether there is an accident or not based on user input and reporting and so on and so forth. So I can see that human aspect will always be in play in some level. But I don't see AI taking control over the world in the foreseeable future, or at least in my lifetime.
Well, that's good to hear, because there's a lot of people that saying, that's the opposite. I hear it on, the news or social media. It's that in 2 years all the jobs will be gone and nobody will have jobs anymore because AI is going to take over everything.
That's a different story. It just depends on the job. I mean, we see robotics and improvements in robotics and stuff like that. So it's depending on the job. And I can't really speak to that because I'm not in economics, and I'm not in the field of robotics, though I do think it's a fascinating field. But I think there may be some jobs that the number of human resources may be reduced substantially. But again, I think there would be at least one or two minimal human presence to address any particular bugs or issues that may exist in an AI implementation. And then, if you think about it this way, and you add another dimension to it, the cost of maintenance when it comes to these sort of AI controlled robotics, I mean, there are costs associated with it. So you just have to think about it in that standpoint, and I can't foresee in the near future that people would want to spend this much unless they're like a multi-billion-dollar organization and can afford it. But there are additional maintenance costs that would be associated with any technology, even just current vehicles as we're utilizing them now. There's always some costs associated with it, and to that respect, we don't know what they are.
Sure. No, totally on the same page. So pivoting a little bit to my last question, more on, again, the human side, but more specifically to your role. I mean, now you're in a leadership role. You're the VP of data science for, Evolve 24. And we've talked a little bit about this offline too, but just in terms of, building a good team, you're in a leadership role, you're building out a team right now. I guess from that standpoint, could you just walk me through, how you're going about it, and how you would recommend, any other business leaders to build out a good team. Because at the end of the day, if you're running a company, you're running a business, a lot of it, almost, pretty much all of it comes from, the people that you hire, your employees, and working as a good team. So could you walk me through just, what your recommendations are and how you go about building a really good team, from that standpoint?
Well, to address that, I've been at Evolve 24 for almost 4 months now, so I'm still fairly new. But I inherited a great team and a diverse team. And when you enter the field of data science, which is mathematically based, if you're in that field, you want to learn something new. You want to gain exposure to new algorithms, mathematical techniques, technologies, so on and so forth. And I think that having that drive is one key factor, the willingness to learn, being able to consume other third-party resources, being able to see the pros and cons of each technical capability. I'm one of the few that I've come across where I would consider myself a full stack data scientist, being able to create something from start to finish, and being able to deploy a model, but ensuring that the performance of the model, not only from a prediction standpoint, accuracy standpoint, but also, how fast does it perform? So stuff like that. I take what I learned from software development and engineering, and that experience, and also from my database administration experience, and kind of balled it up into my current role as it is today, and being able to clearly express what the needs are to my engineering counterparts, but also what I require from a team standpoint. And when it comes to building my team, the personality is and fitting into the culture is very much key. Having that drive, having that enthusiasm, and loving what you do and loving to learn. I mean, I tell everybody this, that I probably will die in front of a computer because I love what I do. And being able to, acquire new knowledge in the field of mathematics. I like my team to be well-rounded. So like I said, there are many branches of data science. So I like somebody who's well-versed in statistics. I like somebody who's well-versed in operations research. I like people who can do computer vision and natural language processing, because if you grow that sort of well-rounded team, you get viewpoints from different lenses. And I think it's very, very much important to have those different perspectives when it comes to addressing a particular problem, because building a sophisticated data science implementation requires a lot of thinking, and it requires a lot of data manipulation and processing, and being able to get that critique from a different lens is quite key and very, very important when it comes to collaborating as a group. My team, I've been building a more well-rounded team. I just recently had a machine learning engineer interview position, and I was looking for a particular skill set that has been exposed into the machine learning engineer mindset when it comes to producing code that's reusable, being able to put models into a production format. I'm trying to revamp how us data scientists work as a whole when it comes to experimenting and turning out proof of concepts very fast. I want to be able to assist and work on problems that can easily be deployed in a fast pace, so that we can, one, gain more clients, but two, also engage and potentially provide ideations to existing clients. And I've been fortunate enough where I have the flexibility where I can hire the right skill sets for different positions and different contracts. And I think being able to understand what the needs of the organization are, as well as understand data science as a whole, is very, very important when it comes to being an executive in the data science realm. I wouldn't well, if I was in a lower position, I wouldn't like to report to somebody who hasn't done my job. I, at one point in my career, was reporting to a director of application development who hadn't done application development. It just doesn't make sense. In data science, you have to be able to understand and break down mathematical models even to the granular standpoint, but also assist in being able to mentor and develop the skills of the team as a whole, and them being receptive to your recommendations as well as team member recommendations, and not to take things personally. Mathematics is a very complex field. It requires patience and it requires understanding, and it will sometimes give you a headache if you studied mathematics. But in the long run, when you work together and come out with an end product, it's a teamwork effort. And I think that when I build my team and as my team grows, I don't want any data scientists to feel like they're siloed in a particular project. I'd like at least one additional data scientist or data analyst or machine learning engineer being a backup, so that they understand what the needs are, what the project is, and to ensure that the data scientist has time for vacation, because, believe it or not, people in our field do have lives outside of work. We like to have fun too. And when it comes to me as a manager, I can say that I am quite eccentric when it comes to my personality. And I do have a sense of humor, and I try to make things fun for everybody. And I want people to also do what they want to do. I want to understand what their interests are, and try to understand and see if there are problems that can be addressed that also fulfill their desires and needs and wants as they want to grow. And I try to ensure that I put them in the right path as they try to grow their skill set. Because again, what it all comes down to is being able to have a well-rounded team that's well-versed and that can kind of understand all facets when it comes to developing products for various clients and consumers of the products that we develop.
Sure. No, it's a really good overview of, how you're building the team from just a personality standpoint as well as a skill set. And then at the same time, you're giving them that autonomy too, to naturally do what they do best, which I think is, really cool that, you have that management, style from that standpoint. It's not sort of a, kind of a micromanagement, like you need to do this and the way that I wanted to get done needs to get done that way. I guess just one follow-up question I'd have would be, how would you go about addressing, say, for example, one of your team members is really struggling with a particular, issue, whether it's a bug or whatever else the case may be. How do you go about helping that employee succeed and ultimately helping the team succeed in a situation like that? I'm sure you've already faced a couple of those situations that you've been on the job. So I'm just curious to hear, how you go about solving problems from that standpoint.
Well, in data science land, a bug or an issue, and let me back up a little bit. There's this misconception, and I've come across it recently as well, that that data science is synonymous with engineering, and that's not necessarily the case. So a bug in engineering is different from a bug in data science. A bug in data science can be whether or not the model is not performing as well as you'd like. And it could be dependent on the algorithm that you're using. It could be dependent on the combination of algorithms that you're using. It could be a combination, whether it's a geospatial or temporal problem, or the combination of both. It could be because of how that model is broken down or not being broken down. It could be how you're aggregating data in the pre-processing phase. It could be so many things. But when it comes to that, I use this analogy a lot. I kind of like to peel the onion. So I asked them, okay, what's the general problem you're coming across? Okay. And then from there, what are you doing here? 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 Just trying to gauge and understand. And I want to also understand what they try to do. And as you're trying to peel that onion, you know, sometimes you have to dig in so deep where you have to analyze each of the data points that you're utilizing, and coming up with those general statistics and patterns and ensuring that you're cleansing the data properly. I'm not sure whether or not if they perform lots of experiments, because experiments can be a combination of data manipulations or a combination of algorithms or a combination of both. I mean, there are all these sort of possibilities. But I think when it comes to the initial phase of building a proof of concept and seeing whether or not it can be done, when it comes to defining what the requirements are, I say it at a high level at first. I'd like a model, ideally, I'd like a model that performs well 80% of the time. That's what I'd like at a bare minimum to say that this is a good model. If it performs 70, it's okay, it still can be used, but let's see if we can improve upon it, because there are different methodologies that we can utilize. And it's just dependent on the data set. So I would recommend a few approaches, and if needed, I also would have additional data scientists to also look at this problem and allocate the resources accordingly. It just depends on the prioritization of the model. It depends on the resources that are available, and being able to work together as a group to come up with the right strategic approach when it comes to how we sort of break down the model, and the issues that may arise and be the cause of quote unquote bug in the model. So I think it's very, very important to educate my data scientists as to, you know, the certain mentalities that they should take when it comes to approaching a particular problem that they're trying to solve from an AI machine learning standpoint. So once they have that right mindset, then they can kind of anticipate the type of questions that I'm trying to ask them, and then being able to clearly articulate, you know, if I tried this, this is what happens. If I tried this, this is what happens. If I tried this, this is what happens. And then if it's impossible to reach that, you know, 80% threshold, we report it as it is. You know, at least we have a baseline metric, and then we iterate through the next version 2, if you will, and to improve the model and take additional approaches. So it depends on the timelines, it depends on the priority, it depends on the number of resources and the amount of due diligence that they performed when it comes to assessing the current state of their model. But again, you know, I'll be the first to admit that I don't know everything, and I rely on my team members to be able to collaborate and again give that different point of view that I may miss. So I think it's very, very important to maintain that sort of relationship with my various team members and ensure that all angles are looked at and saying that, yeah, we tried this, and they can clearly explain why they did this, So it becomes more of a challenge when you're trying to communicate to business, but to business stakeholders, if you will, because that's also our job. We have to clearly articulate that in this version that this model performs well and it answers this questions, but it also depends on whether or not certain business questions are more important than other business questions. So there's that sort of balance and trade-off that we have to take into account when it comes to collaborating within our group, but also with the product and business side of things.
Sure. No, that sounds like a really, you know, clear set way to, you know, figure out, you know, basically solutions to your problem. And then, you know, if something is, you know, the best it can be at that particular time, then you'll run with it and come back to it later. And it's kind of similar to, I mean, obviously, you know, your team is completely different than someone in a different organization, but the concept kind of remains the same of having a team that works together, that each has their own particular skill set. And then when they have an issue or a problem, you try and look at it from every different angle, from multiple different viewpoints. And it's the same thing I've seen, you know, obviously sales and, you know, marketing and outreach is not nearly as complex as data science, right? But even in terms of, you know, cold calling or, you know, reaching out to prospects, how to run meetings, how to overcome other objections. And, you know, you start to hear some of the same things from people and, you know, clients that I've met with and prospects that I've met with. And there's so many different angles you can go about overcoming those or things like that. Same thing from an outreach standpoint too. And, working as a team of like, hey, this is working for me right now, or hey, this is working for me right now, and collaborating on that helps a lot
And
too.
just to give an example, because I was talking about how it relates to business, and a good example is, credit cards. Being able to detect whether a credit card transaction is fraudulent. In some cases, you want to be able to, well, in most cases, you want to be able to detect the fraudulent transactions, right? If somebody else is using your credit card. But then there's the counterpart of that, where I'm sure you've come across, or anybody, at least one time in their life or another, have used their credit card so much where it eventually was detected as fraudulent. Is this a fraudulent transaction? Hit yes or hit no or whatever. And that's sort of like the trade-off of data science. How often do you want to detect the fraudulent transaction, or how often do you want to have it be a false positive of a fraudulent transaction? So it's kind of sort of that trade-off that you have to kind of consider. And finding that right balance is dependent on the business stakeholder. So we kind of translate the problems that we're trying to solve, detecting fraudulent transactions, for example, but being able to break down, the scenarios as to, we detect fraudulent transactions this amount of time, but and we detect it accurately versus, when it's a false fraudulent transaction, or, whether or not it was actually the right user. It's that sort of trade-off that you have to take into account. And then being able to at least understand the existing bottlenecks and being able to address them accordingly.
Sure. No, totally. Well, that's all I got. Thank you guys so much for watching the Horizon Managed Services. This concludes episode 7. Really appreciate it. Thanks, guys.